Okay, let us discuss the next problem. So this says a horizontal plane with coefficient of friction k supports two objects, a bar and an electric motor with battery on a block. So let us say I have a plane. This plane has a friction coefficient k. So friction coefficient is given, that is k. Now this has two objects. One is a small object bar and another is electric motor. So I have a object here bar, let us say, and the next we have a motor. So there is a motor. So let us say there is a motor connected. Now this motor basically has some pulley kind of thing, and this object, so let us say this, I can make this object slightly bigger. So this is one object. And the mass of this object is 2m and the mass of this object is m. That is given in the problem. So a thread attached to the bar is wound on the shaft of the electric motor. So there is a thread that is attached and basically bound in the shaft of the electric motor. And this is attached to the bar. So this thread is basically connected from here to here. So this is here. Now this motor basically can rotate. So there is a battery also inside this motor. So it can rotate. And it is given the distance between bar and the electric motor is L. So distance between here to here is L. So this distance is given to you. So this distance is L. Now any other thing that is given when the motor is switched on. So we switched on the motor. So motor is switched on. So motor is switched on. Now it says starts moving with a constant acceleration w. So this object, when the motor is switched on, the bar whose mass is twice as great as that of the other object, so this is mass m, this is 2m, starts moving with a constant acceleration w. So this starts moving in this direction with a constant acceleration w, let us say. So acceleration of this object is given to you, that is the w acceleration by which this starts moving in this direction. How soon will the object will collide? So what is the time when they will collide? So they will collide. So you have to decide what is the time when they will collide. That means when they will come at the same point. So you have to decide, you have to give me the time when they can collide basically. So let us think this one, how will you do? Let us draw the free body diagram for these two objects. There is a friction coefficient also. So if I make the free body diagram for 2m, so what are the forces that is acting? So there is a tension that is by the motor. Now this has a tendency to go this side, so there is a friction force in this direction, k times mg. Now the normal reaction times n, normal reaction in this case will be 2mg. Mass is 2m, so this is the friction force. Are you getting? Now this object is going this side with acceleration w. Now let us say whatever the force is that is acting on the motor. So this is my motor. So there is a force that is acting in this direction. This is T. Now this motor is going this side, so friction force will act in this direction. Now mass is m, so this friction force is kmg. Now let us say this moves in this direction with acceleration w1. So I have to find basically w1. So I can write equation for this. So T minus 2kmg is equals to mass into acceleration. This is the equation 1. Basically I know the w. I can write equation for object 2. So object 2 I can write T. This is moving in this direction. So T minus kmg is equals to mass into acceleration, so m into w1. So this is my equation number 2. I have to solve for w1. So let us say, what can I do? I basically subtract these two equations, minus plus minus. So if t goes out, so we will have minus kmg. This is equals to 2mw minus mw1. Are you getting? So m goes out. So we will have, so w1 I will have is equals to 2w plus kg. So this is the acceleration of object 2. Are you getting? So let us copy this one. Now let us say that I know the acceleration of object 1, I know the acceleration of object 2. So initially both are having a distance L. So they are separated by distance L. Let us say this moves this side with a distance S1, this moves this side with a distance S2. So I can write, because both are moving from rest, so S1 is equals to ut plus half at square. So acceleration for 1 is w, so half a t square. I have to find what is the time when they can collide, how soon they will collide. So the time, I want to find time, so half a t square. Similarly, I can write equation for 2, so S2 is equals to, so this is equation for 1, half W1, W is 2W plus kg, half W1 t square. And now I can write S1 plus S2 is equals to L, so L is equals to half W plus W1 t square. Are you getting? So T will be 2L by W plus W1 under root. Are you getting or not? So if you plug the value of W1, so W1 is nothing but 2W plus Kg. So this is 2W plus W, so 3W. So you will have 3W plus Kg in the denominator and 2L be on the top. So this is the time required when these two objects will basically collide. Are you getting? So this is a quite interesting thing you can see here. So after 2L by Kg plus 3W under root time they can collide. So what we have learned in this problem, basically we have to find acceleration of both objects. Acceleration of one object is given to you. There is a constant acceleration omega or w. Acceleration of other object can be found using writing down the equation of motion for free body or free body diagram, and then you just use the s is equals to ut plus half at square, you will get the answer. I think you have copied this one. So let us say if you are missing something from top, you can copy from top. In this problem, only important thing we have is we can write down the free, we can separate the body and we can write down the free body diagram and then find out the acceleration. That is the only thing we have. Friction forces will also be there because these two objects will move towards each other. So direction of friction forces is also a good thing that you have to decide yourself. So let us say how many of you have not written something. So you can copy this one from top. Okay, let us discuss the next problem.